Hello everyone, and a very warm welcome to Kognito Key. I'm absolutely thrilled to have you here today. In this electrical engineering explainer, we're going to unpack a fundamental concept that literally powers the industrial world around us. Okay, let's get right into it.
So, have you ever wondered how a massive heavy-duty industrial motor knows exactly which direction to spin the second you flip the switch? I mean, it doesn't just guess, right? The answer actually lies in a highly structured, foundational concept we're about to explore today. And I promise you, by the end of this explainer, you're going to see just how brilliant this piece of engineering logic really is. Okay, let's dive into this. What we're really talking about here is called phase sequence. Simply put, in a three-phase electrical system, the phase sequence is the exact order in which the individual voltages hit their maximum positive value. Think of it kind of like a perfectly timed dance, where each dancer has a very specific moment to step forward and hit their absolute peak. Now, the magic number to remember here is 120 degrees, because a full rotational cycle is 360 degrees. Dividing it perfectly by our three phases gives us exactly 120 degrees of separation. In our three-phase system, these three distinct voltages, or EMFs, they all have the exact same magnitude, so they're equally strong. But they don't peak all at once. They're electrically displaced from one another by this crucial 120-degree angle. And this perfectly spaced displacement, that is exactly what creates that smooth, continuous flow of power. To keep track of this 120-degree dance, engineers all over the globe use a really simple, highly visual naming convention. We basically name the phases, or the coils, R, Y, and B. And this naturally translates to vibrant red, yellow, and blue color codes in our electrical systems. It just makes it incredibly easy, and more importantly, safe, to identify which wire is doing what at just a mere glance. So let's look at how those colors actually flow together. When the voltage peaks in the order of red, then yellow, then blue, RYB, we call this the positive phase sequence. You can also just think of this as a clockwise sequence. And because it's a continuous, never-ending cycle, reading it as YBR or BRY, well, that represents the exact same clockwise progression. Now let's see how this builds. If we were to swap just two of those phases, the order completely changes to what we call a negative phase sequence. Instead of red, yellow, blue, the peaks now happen in the order of red, then blue, then yellow, RBY. So this creates an anti-clockwise sequence. And just like before, BYR or YRB would represent this exact same reversed cycle. So the crucial point is, why does this specific order actually matter so much to us? Well, there are two critical real-world reasons why knowing your phase sequence is absolutely necessary for both safety and functionality. First up, if you want to connect three-phase transformers or alternators in parallel, their phase sequences have to match perfectly. Otherwise, you risk a catastrophic short circuit. No one wants that. Second, the rotational direction of a three-phase induction motor directly depends on this exact sequence. Which brings us right back to our opening question. Say you have an industrial motor spinning clockwise with our positive RYB sequence, and you suddenly needed to spin the other way. You don't need to rebuild the whole motor. To reverse the direction of a three-phase induction motor, you simply have to change the phase sequence of the supply given to it. You literally just swap two of the supply wires, say changing RYB to RBY, and the motor will instantly reverse its rotational direction. It's really that simple, and it is that powerful. I really hope this explainer made the concept of phase sequence crystal clear for you today. If you found this explainer helpful, please hit that subscribe button to join us here at the Kognito Key channel. And definitely don't forget to like and share this explainer with your fellow engineering learners so we can keep demystifying these fascinating topics together. But right before we go, I want you to think about this. If swapping just two wires can entirely reverse massive industrial machines, what other incredibly complex engineering problems might have super simple, elegant solutions just waiting to be found? Keep wondering, and I'll see you in the next one.